In this section, we're going to talk about momentum and what momentum means and what the change in momentum does. Okay, so today what we're going to talk about are the first three things on here: momentum and impulse, and what impulse is and how impulse changes momentum. Okay, first let's talk about momentum and what it is. So momentum is a property of moving things. So all moving things have momentum. And it means inertia in motion. Now, if you remember what inertia is the tendency of a body to resist a change in motion. And in particular, inertia really has to do with mass. The more mass something has, the more inertia it has. So if we're talking about the property of moving things, so it has to be moving, so it has to have some sort of velocity, and it has inertia, so it has to do with mass and velocity. Now, more specifically, we're going to say that momentum is the mass of an object multiplied by its velocity. So here is the equation for momentum. So this is what you need to know, that momentum equals mass times velocity. So whenever you're calculating momentum, you just take the mass and multiply it by the velocity. Okay, so here we have an example of momentum in action. So we have a boulder that's rolling. It's moving down this mountain. Now, if we had also a stone rolling down the mountain at the same time with the same speed, the boulder has more momentum than so the stone has less mass. Let's wait for the slide to come back up. Okay, the stone has less mass. Now remember that that momentum was velocity. So we have momentum, and momentum equals mass times velocity. So if we have a boulder and a stone moving at the same speed, then what we can see is that since the boulder has more mass, then it will have a greater momentum. And the stone will have a less momentum, because it has a less mass. So if two things have the same speed, the one with the more mass has the greater momentum. Okay, now, on the other hand, let's say we had two boulders and one was faster than the other. Well, then the faster one has more momentum. So going back and looking at our equation again, if we look at the mass times velocity, if we have two things that have the same mass, exactly the same mass, then the one that's going faster has the greater velocity. Okay, now if we have a boulder at rest, it has no momentum at all, and it has no momentum because in our equation that we had that momentum equals mass times velocity. Even if it has some mass, if it's not moving, it has no velocity, and so if it's not moving, that means it has no momentum. Okay, so let's take a look and make our prediction on this question. So a moving object, does it have momentum, energy, speed, or all of the above? So let's think about this. So it's moving, momentum, energy, And remember the different kinds of energy. You have kinetic and potential and speed. And the answer, if you guessed, was all of the above. And we're going to see that the energy that it has is called kinetic energy. So anything that's moving has kinetic energy. Since it's moving, it has some speed. And since it has some speed, it has a velocity. And if it has a velocity, then it has mass times velocity, which is momentum. Okay, so let's look at this one. When the speed of an object is doubled, what happens to its momentum? So our choices are remains unchanged in accord with the conservation of momentum, which we haven't talked about yet, or it doubles, quadruples, or decreases. Now before we answer that, let's think about our formula. Okay, so momentum, and by this time you should know the formula. Momentum equals mass times velocity. And the question is, what happens if the velocity doubles? Well, sometimes you can do these kinds of questions, these conceptual questions, just by saying, okay, well, it doesn't matter what numbers we have, so let's just see what happens. Let's say that we have a mass of 1 kilogram and a velocity of 1 meter per second. Well, then our momentum would be 1 kilogram times 1 meter per second, which is 1 kilogram meter per second. Okay, now let's say our velocity doubles. Okay, then our momentum would be 1 kilogram times 2 meters per second, which is 2 kilogram meters per second. So when the velocity doubled, what happened to the momentum? It also doubled. So you can just think about it that we're saying mass times velocity, so if we multiply this by 2, we're multiplying the whole thing by 2. If the velocity triples, what do you think happens to the momentum? It also triples. If the velocity is in half, what happens to the momentum? It's cut in half. Okay, so our answer here is doubles. Okay, now let's talk about impulse and what impulse is. Okay, so our formula for impulse, let's go back. Whoops. Our formula for impulse is force times time, so you need to know that. So impulse is the product of force and time. Impulse is force times time. And so our example is, if we have a brief force applied over a short time interval, that's going to produce a smaller change in momentum than if you have the same force applied over a longer time interval. Now let's look at our formula and see what that means. So we have a force and we apply that over a short time, then we have a small impulse. If we have the same force but a long time, then we have a big impulse. Well, what does this impulse do? The impulse changes the momentum. And so if you apply a force for a greater period of time, you're going to change the momentum more. Okay, well, what happens if instead of changing the time, you change the force? So if you increase the force, then you also increase the impulse. So if you think about it in another way, let's look at the time again. If you push with the same force for twice the time, then you're going to have twice the momentum, or twice the change in momentum. Just like we had with momentum when we doubled the velocity, we doubled the momentum. Here, if we double the time, we'll double the impulse. Okay, so what does impulse do? Impulse changes momentum. So the greater the impulse exerted on something, the greater the change in momentum. And so here's our formula. Force times time equals the change, that's that delta, our change in momentum, and that's our formula for momentum. So this is impulse. Impulse, force times time, equals change in momentum. So this guy pushing the car, if he pushes for a longer time, then the car will end up having a greater velocity. If he pushes with a greater force, then the car will have a greater velocity. So all that makes sense. Okay, so let's take a look at this. When the force that produces an impulse acts for twice as much time, the impulse is not changed, doubled, quadrupled, or halved. Okay, so let's look at our formula. Okay, so here we're going to be talking about impulse. Let's remind ourselves of what the formula for impulse is. Impulse equals force times time. Now the thing to remember is what that also equals is change in momentum. So if this is our formula, force times time, if we multiply this by 2, then we're also multiplying this by 2, which means our change in momentum is twice. And let's look at that with some numbers. Let's say our force is 1 Newton and our time is 1 second. Okay? Then our change in momentum is 1 Newton second. Alright, now let's say that we double the force. If we double the force, then we'd have 2 newtons times 1 second, which is 2 Newton seconds. So what happened to our impulse? Our impulse doubled. So you double the force, you'll double the impulse. The same thing would happen if you double the time, then you will also double the impulse, which is the change in momentum. Now let's look at our units here. Our units are Newton seconds because we took a force times a time. But we also said it's change in momentum. And what are the units for momentum? Well, remember, momentum is mass times velocity. So our units there would be kilograms times meters over seconds. So those are our units for momentum. Well, that has to equal our units for impulse. So a kilogram meter per second has to equal a Newton times a second. Well, how can that be possible? Well, if you remember, a Newton, 1 Newton, is 1 kilogram meter per second squared. So if I multiply 1 Newton by 1 second, then I take 1 kilogram meter per second squared times a second. Well, this second cancels with that second, and I get a kilogram meter per second, which was our units for momentum. Okay, so when the force that produces an impulse acts for twice as much time, what happens to the impulse? Not changed, doubled, quadrupled, halved. And the answer is doubled. Okay, so impulse causes a change in momentum. So let's look at case 1, increasing momentum. If you want to increase momentum, there's 2 ways to do that. The first way is to apply the greatest force, because if you increase the force, you increase the momentum. The other way to do it is to increase the time. So you apply to get the most momentum, you apply the greatest force for as long as possible, and you extend that time of contact. Now that force can vary throughout the duration of the contact, because really when we look at our formula for impulse, it's force times time. That force can change, so we're really looking at the average force. So when a golfer swings a club, he's going to follow through. That's why you're supposed to follow through when you do sports, because you're increasing the amount of time that in this case, your golf club is in contact with the ball. When the baseball player hits the ball, he follows through. So why is that? Because it's force times time. So the longer you're in contact, the more the change in momentum. Okay, so let's look at this example. A cannonball shot from a cannon with a long barrel will emerge with greater speed. So we have a long barrel. Why would it emerge with greater speed? Well, let's think about what we just said about momentum. We said we want the greatest force for as long as possible. So why would we have more speed if we had a long barrel? Well, the answer is it has a greater impulse because it's a greater force. Well, it's the same force, but over a longer period of time, just like the baseball player. So we have the average force is going to be the same whether you have a short or long-barreled cannon, but you have a longer barrel, So you have a longer time for the force to act. So our impulse, which is force times time, has a longer time. So then it has a greater impulse. Then we're also going to see in a later chapter that means it has more work and greater kinetic energy. Okay, what's our way to decrease momentum? Well, same idea. You extend the time during which the momentum is reduced. So here we're applying a force to reduce the momentum. And when we do that over a longer period of time. So if you want to decrease the momentum, you apply that pull or whatever it is that you're doing to lower the speed, and you do that over a greater period of time. Okay, so let's say we have a fast-moving car, and that fast-moving car hits a haystack or a cement wall. Well, what's going to happen? Well, you know, just thinking about it, you hit the haystack and the car ends up being full of hay. You hit the cement wall and your car crumples. So let's think about why. Okay, so let's think about our formulas here. Let's think about our formulas. Okay, first we have momentum. Momentum equals mass times velocity. Okay, so we're going to start with the concrete wall. And we know that, and we'll have the haystack. At the beginning, so this is the beginning, does the car have the same mass in both instances? Yes. And we're going to say they're starting with the same speed, so same velocity, whatever it is, okay, same mass, same velocity, so that's just mv, whatever it is, and you'll notice it's the same for both of them. And at the end, so we have the concrete wall and the haystack, at the end, do they have the same mass? Does the car have the same mass in both instances? Sure. And what's its velocity at the end? So after the car has crashed into the haystack or after the car has crashed into the concrete wall, the velocity is 0 in both instances. So at the end, we have the velocity is 0. So for the concrete wall, the change in momentum is mv minus 0, which is mv. What about for the haystack? It's exactly the same. But now let's look at impulse. Impulse is force times time. And let's think about our concrete wall and our haystack. Now here, remember what we're doing is we are decreasing momentum. So we are having a change in momentum, but our change in momentum, actually I should have done this backwards, because the change in momentum is the final momentum minus the initial momentum, so we have a negative mv. And so we have a decreasing momentum. And so the bigger that absolute value, the bigger this number is, the bigger the change, then the more the change in momentum. Well, what happens with the concrete wall or the haystack? We have a smaller time. And with the haystack, we have a bigger time because it takes a very short amount of time to go from your original velocity to your 0 velocity if you hit a concrete wall. But it takes longer if you have a haystack. So in this instance, what's happening is as we're decreasing our momentum, we have, and I think I said it backwards a minute ago. So as we're decreasing our momentum, this one happens faster than this one does. And so since we have the same change in momentum, so we have minus mv in both cases, so minus mv, and in both cases, We have force times time. This is a different force. That's the force for the concrete wall. That's the force for the haystack. Now, we know this is shorter for the concrete wall. So the time is shorter for the concrete wall. It's longer for the haystack. But since the change in momentum is the same for both of them, since this change is the same, then if this is smaller, this has to be bigger. If this is bigger, this has to be smaller, because their product is the same. So if we have a shorter time, then our force is bigger. If we have a longer time, our force is smaller. Well, what does that mean in terms of our car? Well, with our car, if we have a bigger force when we're hitting the concrete wall, then we have that bigger force being applied to our car, which means that the car is going to crumple, whereas with the haystack, we have a smaller force. So let's take a look at what our question was asking us. So, a fast-moving car hitting a haystack or a cement wall produces vastly different results. Do both experience the same change in momentum? Yes, they both go from an initial velocity to a zero velocity. Do they have the same impulse? Yes, because change in momentum is impulse. Just keep that in mind. Change in momentum is impulse. Do both experience the same force? No. The hitting the cement wall has a greater force because it has a smaller time. So look at your choices. And the answer is yes for 1 and 2, because the stopping the momentum is the same whether it's done slowly or quickly, but the force is very different. So you need to make sure you keep in mind the difference between momentum, impulse, and force. When a dish falls, will the change in momentum be less if it lands on a carpet than if it lands on a hard floor? Now be careful, it's asking for change in momentum, not force, just change in momentum. And the answer is both are the same, because remember, change in momentum is just talking about the change in velocity. It has the same velocity right before it hits the floor, and it has 0 when it comes to a stop. So the change in momentum is the same. So the momentum becomes 0 in both cases, so they change by the same amount. And so the momentum and change in impulse are the same. Momentum is change. A change in momentum is impulse. But the force is going to be different. The force will be greater when the time is smaller. Okay, so when a car is out of control, it is better to hit a haystack than a concrete wall. You already knew that. But why? Same impulse, but because of the amount of time, if you have more time, that reduces the force. Bigger time, less force. Okay, when you jump, when you hit the ground, you bend your knees. Why do you bend your knees? You bend your knees because that gives you more time. So if you have more time, that decreases the force. Now, I've never boxed, but the idea with boxing is when if you keep your head, in this instance, steady, then that's going to decrease the time, and so you'll have a greater force. But if you move your head back, then you will increase the amount of time, and then therefore you'll have less of a force. Okay, now what do you want to do in karate? Well, this is going to be the opposite. You want to move swiftly because you want to have a small time, and that will give a bigger force. So since the time of contact is brief, the force is huge. Now, you would have the same change in momentum if you went well, I mean, it depends. I don't know. I don't do karate. But the idea is you want to move your arm and hand swiftly against the bricks with considerable momentum. You want to have a lot of momentum. And since the time of contact is brief, the force of the impact is huge. Okay, so next time we'll talk about bouncing. And so we're done for here. Let's look at some problem solving. Okay. Okay, so what is the momentum of a 10-kilogram cat moving at, let's see, how fast is this cat moving? He's moving at 5 meters per second. He's in a hurry. Okay, so what is the momentum of that cat? Well, momentum equals mass times velocity. So it's 10 kilograms times 5 meters per second equals 50 kilogram meters per second. Okay, let's look at an impulse problem. What is the impulse when a 3 Newton force acts over a period of 6 seconds? Okay, remember your formula for impulse. Impulse equals force times time equals 3 newtons times 6 seconds, which is 18 Newton seconds. All right, let's look at a change in momentum problem. What is the change in momentum when a 7 Newton force acts over a period of 4 seconds? Okay, what you have to remember here is change in momentum equals impulse. So what's our impulse? It's force times time, or it's 7 newtons times 4 seconds, equals 28 Newton seconds. And remember, a Newton second is the same as a kilogram times a meter per second. So that's the change in momentum. All right. What is the impulse when a 3 kilogram object moving at 5 meters per second comes to rest in 2 seconds? Okay, so what is impulse? Impulse is change in momentum. Okay, how are we going to write change in momentum? Change in momentum will be our final momentum minus our initial momentum. What's our final momentum? It's our mass times our final velocity. What's our initial momentum? It's our mass times our initial velocity. So it's coming to rest. So the final velocity is 0. So mass times 0 minus mass times its initial velocity. So mass times 0 is 0. The mass here is 3 kilograms. Its initial velocity is 5 meters per second. And so that gives us an impulse of minus 15 meters per second. Now let's say I asked a different question here. Let's say instead I wanted to know this, I have the same setup, but I want to know what is the average force. Okay, well then I have to do an additional step. So I've already done all of this, and then I remember that impulse equals force times time. Well, I got the impulse here. It's negative 15 meters per second. Force is what I'm looking for. I don't know the force. And force times time. I do know the time. The time was 2 seconds. So that's a times there. So to find the force, I divide by 2, and my force equals negative 15 divided by 2, or negative 7.5 newtons. Okay, so those are some problems for you. Probably won't get this hard on the homework, but you can go ahead and look at that and see how it works. And then there are some homework problems for you to do online.